Hi guys, in this video we learn more about what is ASCII, why does it matter, and how can we write a program in C language that can print the ASCII table for us. ASCII stands for American Standard Code for Information Interchange. It's a very old character encoding standard and it's used to map every character to a number. By every character, I mean a limited set of characters that is mostly based on English language characters. So ASCII does not include any Japanese character or Arabic characters and so on. It's an old encoding and it uses 7 bits of information to represent or encode a character. To see the table of ASCII, you can just write in terminal man ASCII. And if you just hit the space, here you will see the decimal set, which represent the ASCII characters in the decimal format, so it's easier to understand them. And you can see it's a number from 01 to 127, which is represented by 7 bits. And every number maps to a character. So some of these characters are not visible on the screen. And some of them are just easily visible, like 1, 2, 3, or English letters, or like just some signs and things like that. So if you just come to your terminal and type locale, you will see that it says something .utf-8. Probably it will be UTF-8. So your system uses a different encoding. But why does ASCII still matters even if it's an old encoding system? So because of compatibility of old systems and new systems, the new encoding system, which is UTF-8, it also implemented in a way that first 127 encodings are exactly mapped the same as ASCII. So it means that ASCII encoding still works in the newer encoding system. So that's interesting. And what we're going to do here is to write a program in C that can print sort of this table for us. So let's go to the code and see how can we write that. I start by creating a program called ASCII Table.c. Then I use the standard IO library and I define the main function. Then I like to have a loop from 0 and go so on until 127. So I just come here, create a variable, integer variable called int, and we can just call it n. Then I start a for loop and say n is equal to 0 until n is less than 128. Just do n++ or add 1 to n at every evaluation of this statement or expression. And in the block of the for loop, so we can just simply start with a function called putchar, which puts or prints a character, just a single character, in the output. So just put n. And you may be wondering, okay, then the n is an integer, and if you pass an integer to print it, will it print the integers or will it print the encoded characters? So let's try it. I come to my terminal, I compile it with Clang, and then I say ASCII Table-o ASCII. And if I run ASCII, it will print the actual characters for me, not the number. And that's interesting. So that just shows that all of the characters that we are dealing with are actually numbers, and this is just a way of representation. All right. So we want to have a sort of table that we show both the number and the real character. So for that, what I'm gonna do is I'm gonna print the character 9, which is horizontal tab, just to make a tab. So for every character, after I printed it, I just put char 9 to create a horizontal tab. Yeah, we also have a vertical tab, but it's not so common in these days, so that's why we have two kind of tabs. We just know the tab by horizontal tab right now. And then I just want to go to the next line. Let's say, so I put char 10, and because 10 represent the next line. So come here, compile again and run again. And there we go. You can see that every character now is in a separate line. And you can see we see a lot of empty lines here. And that's because the first characters or the first encodings we have in the ASCII, almost all of them are not visible in the output. Some of them are, like for example new line or horizontal tab, they are, but most of them the other ones are not visible. So okay, now what I want to have is to have the number before the tab or after the tab. So I can just come here and use printf, and just I can put %d because we're gonna print the number, and then put the n and print it. So now we're gonna print the character, then print the tab, then print the number, and then go to the new line. Let's compile this and run this, and there we go. We have a small tiny ASCII table, and as you can see here, we print some characters but they are not visible. And for some of them, like for example number 9, which is tab, now we have 2 tabs, and for new line we have 2 new lines. So it's interesting. Another interesting thing is number 27, which if you look at here is for character escape, and it prints in a strange way here, but that's just a way that my terminal in VS Code interprets that. So if I come here in my terminal, in my just normal terminal, and I try to run the same program, I will see that it prints normally here. So this is just a matter of how different terminals will treat the escape character. And perfect. So we learned how to use putchar and how to print the ASCII table, and we also got familiar with the ASCII table. There is one more thing that we can add to this program to just making it more easier to read, and that's something called symbolic constant. As you can see here, I start from 0 and go to 128. Then I put char 9, then I put char 10. These numbers may be a bit not clear for a person that reads our code. So it's better to use symbolic constant. And the way we use is like this. Say define, then put a name for that, like max ASCII length, and put the value for that. So now we can replace this with this, and we can define another one for tab, and just put it to 9, and we can define another one and call it new line and give it the value of 10, and then we can just replace tab and new line. Yeah, as you can see, it's much easier to read right now, and as our programs got bigger and bigger, the need for using the symbolic constants will be more serious. Thank you so much, guys. I hope you enjoyed this video, and that's it.